All right, folks, so looking at the Unit 4 Part 1 review, in this first section, you are identifying each property for the graph. The zeros you can write as x equals values. Zeros are the same as the x-intercepts. The y-intercept, read it directly from the graph, being careful with your scales. Notice that this, in the middle of 0 and 2, is 1. So then what are each of the boxes worth? Half. So be careful as you are pulling out values. The y-axis does go by ones, but the x-axis goes by 0.5s. The axis of symmetry, make sure you have x equals a number, because that needs to be the equation of a vertical line. If you tell me the axis of symmetry is just a value, you will lose points. The vertex, it's a coordinate. For the end behavior, make sure you have the notation correct. As x goes towards negative infinity, what's my function doing? And as x goes towards positive infinity, what's my function doing? So if that was something that you struggled with in Unit 3, make sure you got it down for this unit. Domain and range, you can use interval notation or inequality notation. I don't care which. For graphing each function, this is important because I had to flag a lot of people's homework for this. You must show your axis of symmetry work. So must show your A of S work and the table of values. So don't just plug and chug points and put them on your graph. Actually show that collection of points in your table. Remember, you have to keep going until you find the zeros or the x-intercepts. If they are between two values, say which values they are between. Any questions on that first page? All right, moving on to the second page. So this is the section that is just on factoring. So you aren't going to be solving anything here. We're not actually getting values for x. We're just trying to break this down into something times something else, possibly times another something. So we just want it all to be multiplied together into factors. What's the very first thing we check for when we're factoring? GCF. Always, always, always check for a GCF first. And then there's the monic factoring or normal factoring. When A is equal to 1, looking for a product of the C value and a sum of the B value. And then the non-monics, which is when A does not equal 1, and we use the X method. You don't have to show me that you can do the X method. I know that some people like to do the box method or use guessing and checking. So I don't care how you factor, but you have to show me that you can do it. I will also be watching closely for cheating. So eyes on your own paper at all times. If you're not showing work, I am going to be a little suspicious. So make sure that you are showing evidence that you are trying combinations. So that's 4.2 with factoring. 4.3 is going to be our operations with complex numbers. So complex numbers, remember, are I. They have to be written in that A plus BI form. Real part first, imaginary part second. Remember the square root of a negative, we automatically bring out an I. And what's I squared equal to? -1. My other big recommendation for this section in the test is make sure that you are keeping track of your operations. This one is not foiling, even though I have two sets of parentheses. It's got a minus sign, so we need to distribute the minus sign first and then combine our like terms. Number 13 is foiling, and number 14 is multiplying. Questions on that page, or did everybody get that top part written down? All right, moving on to the next page. For solving quadratic equations, I'm not going to make you describe the roots. However, it's a good thing to keep in mind. Use your calculator to check. However, you must show work. That work should either be factoring work.
Do you have a graphing calculator by any chance?
Yeah, who are you coming from?
Miss Felt.
Yep. There you go.
Thank you.
So you can use your calculator to check and to determine the types of roots that you have, but you must show work for solving. So no matter how much you use your calculator, I should either see factoring work or what? What's the other way we solve? The quadratic formula. I think what I am going to do is somewhere on the test, I will have you write down the quadratic formula, and then I will come around and check it. You will lose points if it's wrong from the get-go, but that way, if you're using the quadratic formula to solve, you will have the correct version. So you'll be responsible for writing the quadratic formula, and during the test, I'll be checking people off, and I'll be marking what parts you got right or not right, but then you will have the correct formula to use for solving. Does that make sense? Alrighty, so you must show work for solving, factoring work, or the quadratic formula. Do these problems carefully, and remember, you can use your calculator to check yourself using y equals, using the trace button. Those are all ways that you can check yourself. So there's a lot of these problems on here. You are free to show work on an additional piece of paper. Scratch paper is all up here in these two stacks. So this is scratch paper, that stuff is not. So if you do need extra paper to be showing work on, feel free to grab some from over there. I think that's it. So I think what I'm going to do is just give work time. But if you would like, or if you feel like you need the practice, I will go through some more of those guided practice problems. So, or would you guys rather have work time first? Work time first, and then maybe in like 20 minutes we go over more of these? Okay, let's go ahead and do that then.